Hi everyone. Today, our team will be giving a presentation on analytic hierarchy process analysis, known as AHP analysis. We will be covering an introduction to AHP analysis, what AHP is used for, how is AHP conducted, and the advantages and limitations of using AHP. To help viewers better understand how AHP analysis works, we will be applying it to a decision-making scenario in the context of a hospital. Firstly, what is AHP? AHP is a logistic decision analysis method. It makes use of a structured technique to organize and analyze complex decision-making scenarios, especially those that involve multiple criteria. It simplifies the number of variables that the decision maker has to take into account simultaneously from many to only two. But why do we need such analysis method? The most important reason will be that many decisions that need to be made today are extremely complex in nature. Imagine choosing a school for your child. This so-called simple decision has many factors that need to be taken into account. Friends, cost, distance, and the list goes on and on. AHP analysis helps to provide a simplifying framework for such complex decisions, thus allowing us to make decisions effectively by expediting our natural decision-making process. Secondly, decisions are often made based on judgment on already complicated reality. Here, AHP not only takes into account our feelings and intuitions in decision-making process, but also reduces the complexity of comparing many variables to just two at a time. Often, two exclusive approaches can be used in decision-making. Deductive approach focuses on details. Inductive approach focuses on the whole. AHP combines these two approaches, making it an integrated framework. So, how is AHP done? The first step to solving any problem is breaking down the problem. AHP requires the decision maker to be clear on the main goal of the decision, the criteria that are important in achieving that goal, and the candidates that can choose from to solve the problem. Next, we will compare the criterion to another using pairwise comparison to rank the criterion in order of importance. To do this, we will assign numerical values based on the table for each pairwise comparison. For every two criterion, the decision maker has to decide if they are of equal importance or if one has a weak, strong, or very strong importance over the other. Based on that decision, a number is given to each pair. These numbers will form a preference rating matrix. Next, we do some math to calculate the priority vector. This priority vector shows us which criterion has the highest influence in making the decision. After figuring out which criterion is the most important, we will again compare the candidates using pairwise comparisons to decide how well each candidate does over the other in terms of each criterion. The same table in the previous slide is used. N candidates and M criterion will generate n times n rating matrices. Then, we will calculate eigenvectors of each matrix to form a M times N matrix, which shows how well each candidate performed in each criterion in relation to all other candidates. Lastly, we will multiply the two matrices that we have to obtain a final matrix. This matrix shows the overall rating of each candidate with regard to the decision. A higher rating number in the final matrix shows that this candidate is more suitable to achieve the goal and that this candidate should be chosen. These are all the steps in an AHP analysis. There is also a basic assumption that we made. We assume all human judgments made are consistent. For example, if A is ranked as more important than B, B is ranked more important than C, then we assume A should be ranked as more important than C. Hence, we will conduct consistency check on all of our pairwise comparison matrices to ensure our judgments are consistent throughout. We use inconsistency ratio to show how consistent decision maker has been when making the pairwise comparisons. A higher number means the decision maker has been less consistent, whereas a lower number means he has been more consistent. If it is less than 0.1, then we can conclude that the pairwise comparisons are relatively consistent. Inconsistency ratio of a reciprocal matrix is calculated using the following formulas. So now our team will use the following real-life example to demonstrate how AHP analysis is used. ABC Hospital currently uses its employee to transport blood samples around the hospital. Employees have complained that working around the hospital have taken up valuable time from their work. The management echoes the views of the employees and have been wanting to implement a new transport system for some time, but are unable to decide if they should do it or not. Also, with so many new systems in the market, the management is unable to choose wisely. We will be helping the management decide if a new system is needed, and if so, which system will be used, using AHP analysis. The first step of our analysis is breaking down the problem. We recognize the need of finding the most suitable blood testing transportation system in order to address the complaints and needs of hospital and its staff. Hence, first, we identify 5 criteria that we use to assess the performance of the transportation system. They are cost, accuracy, feasibility, time efficiency, and user friendliness. Then we did some research and narrowed down our candidates to the following 3 potential transportation systems, which are human, robot, and tube. Here is the overview of the problem. Now, we will arrange these criterions in a hierarchy order using pairwise comparisons. This is done based on our secondary research result. And a preference rating matrix is created using the table shown previously. For example, we believe that accuracy has a strong importance of cost. According to the table, strong importance is represented by 5, so we will put 5 here. Also, we can allocate 1/5 to here as relative importance of cost to accuracy should be the reciprocal of 5. Moving on, from the comparison table we've got in the previous slide, we calculate out the priority vector of the 5 criterion. This is done by calculating the principal eigenvectors of the previous matrix using mathematical software, MATLAB. The result shown tells us the relative influence of each criterion in making the decision. That is, cost has a weightage of 0.086, accuracy has a weightage of 0.526 as extra. Since 0.5261 is the largest among the 5 values, we can tell that accuracy has the highest influence in decision-making process. The assumption check is also done to prove the consistency of the reciprocal matrix. The inconsistency ratio is 6.2%, which means our pairwise comparison is relatively consistent. Then, 3 transportation systems will be rated with respect to each individual criterion. We will use the first criterion, cost, to demonstrate the process. Based on the research result, we believe that human method is the most economic among the 3. From the financial aspect, it is favored very strongly over the tube method and quite strongly over the robot method. According to the rating table, 7 and 5 are entered respectively. The same process is repeated for each criterion. Then, we find out relative performance of candidates in each criterion. This is achieved by using the same mathematical method as calculating priority table. We still use cost as example. We can see that human has a relative performance 0.73, which is highest among the 3. Consistency check is done again on the previous 5 pairwise comparison matrix. The inconsistency ratio calculated as smaller than benchmark 10%. Hence, we are confident that our pairwise comparisons are relatively consistent and we can continue with our analysis. After calculating the relative influence of each criterion and relative performance of the candidates in each criterion, we do a simple matrix multiplication to obtain the overall rating of the candidate. From the last column of the table, we can tell that human method has an overall performance of 0.311, tube system 0.4566, and mobile robot 0.2323. Since tube system scores the highest among the 3, we will recommend the hospital to implement the new blood testing transportation system using tube method. AHP provides a single, easily understood, flexible model for a wide range of unstructured problems. It also does not insist on consensus, but synthesizes a representative outcome from diverse judgments. It checks the logical consistency of judgments based on determining priority. Lastly, it also provides a scale for measuring intangible and a method for establishing priority. However, it has limitations as well. AHP has been considerably criticized for its possible rank reversal phenomenon, which means that the relative rankings of 2 decision alternatives could be reversed when a decision alternative is added or deleted. So now we've come to the end of our presentation. Thanks for watching.